All right, we're doing more derivative problems. So last time we learned about implicit differentiation. So now we're going to jump to page 51 where we're doing these derivative problems. So if you remember a couple the first videos I posted, we did problems A through H. Now we're on problems I through the rest of them. So I'm going to go through these problems just like I did last time and do them one at a time and upload them. And so I would encourage you, just like last time, to try them all. And then after you try them, watch the video and see how it's going. So let's start with I. If you haven't had the opportunity to do I yet, I would encourage you to pause your video right now and try it and see how it goes. All right, hopefully you paused your video. If not, well, that was a little awkward then, wasn't it? Okay, well, let's do this one. So we're trying to find the derivative. We're trying to find y prime. And so this one, it's not solved for y. In fact, this is a problem where solving for y is actually going to be impossible. If you tried to solve this equation for y, you wouldn't, well, I guess you could come up with it, but it's really awful. I mean, it has cube roots and imaginary numbers and all sorts of stuff in it. So don't try to solve it for y. Instead, just solve it implicitly. So this is called implicit differentiation. Implicit differentiation, and this is section 2.6. So if this doesn't make sense to you, you should go back and rewatch the 2.6 video or work on some of the 2.6 homework to make sure you're on top of things. Okay, so, but let's do it. So what do we do when we do implicit differentiation? Step one is we derivative everything. Step one is we dx everything. So we derivative this, and this. So we kind of do both sides. So if I take the derivative of the left-hand side, the derivative of x cubed is 3x squared. We're really good at that one, right? Now when we get to the y cubed, it's a little confusing. But if you've gone through 2.6 and you kind of learn the material there, we know the derivative of y cubed is just 3y squared times a y prime, or a dy dx. Why is that? Because think of this as a function where we have y on the inside and cubed on the outside. And so think of it as the inside is y and the outside might be like an x cubed. And then we've got the chain rule, our 3 inside squared, and then we have the derivative, so the derivative of y is y prime, and the derivative here is 3x squared. So it's like we did 3x squared, put the inside back in, 3y squared times the derivative of the inside is y prime. So that's what makes implicit differentiation work. And I would really like if you kind of saw it as just a special case of the chain rule. But if you don't, you can just do the problems and just say, okay, I'm just going to take the derivatives like normal, and every time I take a derivative of y, a y prime pops into the problem. But it pops in the problem because of the chain rule. At this point, students often ask, well, why don't we get an x prime in the problem? Well, you actually could if you wanted. So we could write x prime here. But let's just think about what is x prime. Well, x prime is the rate of change of x. And well, we know the rate of change of x is 1. So x prime is just a constant 1 because x is just a line that has a constant slope of 1. So you could, if you were really wanting to, put an x prime in there, but it would just always be 1. So we never write it down. Okay, sorry, that was a little distracted, but let's keep going. So x cubed, 3x squared, plus 3y squared, y prime, equals, and now let's take the derivative of the other side. The derivative of x is 1. And the derivative of y is 1 y prime. And I don't need that 1 there, do I? I can just make it y prime. Okay, so now that we've dx'd everything, the last thing we do is solve for y prime. And the solving is always the same. The solving involves taking everything that has a y prime in it and moving it to the same side. So I'm going to move my y prime over here. So that means I'm going to subtract a y prime on both sides. And then I'm going to take everything that has an x in it, and so that'll be here, and then I'm going to move all the x's to the other side. So that means I'm going to subtract a 3x squared. And wow, I've now made everything look really ugly but you all are so clever that you're on top of it anyway. So what we get on the left is 3y squared y prime minus y prime, because I subtracted the y prime from both sides. What I get on the right is 1 minus 3x squared, because I subtracted the 3x squared over here. Again, you all are on top of this. Now what am I going to do? The last step is basically the same. Every time we do the algebra, we factor the y primes out. And that means we've got y prime times 3y squared minus 1 equals 1 minus 3x squared. And then the very last thing I have to do, is divide. And so now I will divide by that. And so I get my answer, which is y prime equals 1 minus 3x squared divided by 3y squared minus 1. And there's our derivative, and we're